Hello students. On day 1 of geometry unit, we are just going to review Pythagoras theorem. I know all of you have done this in the past, so we are just going to have a quick review. Remember again that Pythagoras theorem applies only on right angle triangles. So it's very simple. A squared plus b squared equals c squared, and a and b are just the sides which are attached to the right angle. And c is always the side which is opposite the right angle, and this special side is called hypotenuse. So that is very important, okay? C is always the hypotenuse in this formula. So let's look at some examples very quick. Here we have 5, 12, and the hypotenuse x is something that we need to find the length for. So following the formula, we will have 5 squared plus 12 squared equals x squared. So always x is the c, the hypotenuse. And then we know 5 squared is 25, 12 squared is 144, and don't forget that what you have here now is x squared and not x itself. So then you have to square root both sides. So in this case, we need to find the square root of 169, and then we get the final answer. It should be 13 unit. Okay? So here in this case, the next example, the hypotenuse is here. This is C. So 10 is the hypotenuse. So when you actually apply the Pythagoras formula, then we will have to write x squared plus 6 squared equals 10 squared. So this is very important. 10 is the hypotenuse, so it has to come under C. Okay? Right, so then we have here x squared plus 36 equals 100. And then applying a little bit of algebra, of course, we have to subtract 36 both sides. And then we have x squared is 100 subtracted by 36, that's 64. And then x has to be the square root of 64. So in this case, x is 8. Okay? All right, so I just would like to show you something very quick here. In your calculator, there is a very handy button. So here I have that button, and then square root sign is this one. So if you would like to just enter everything in one go, so for instance, in this case, I know x will be square root of 10 squared plus minus 6 squared, then I can just enter it all in one go. So for instance, here, the squared symbol is there, and subtract by 6 squared, and then I just press enter, and then you get the answer right away. So it's a very handy button, this one, for all kinds of mathematics symbols. All right, so let's go to the next slide. Just make sure you remember that this Pythagoras theorem applies actually both ways. So for instance, if you do have right angle triangles, then a squared plus b squared equals c squared applies, and the other way around. So basically, you can also use Pythagoras theorem to check whether a triangle is right angled or not. So for instance, you are given this random triangle here with sides 20, 21, 27, and we are supposed to check, oh, is this a right angle triangle or not? So let's check. If it is, then Pythagoras theorem should apply. Then in this case, assuming it is, then the hypotenuse should always be the longest side. So this should be C, the hypotenuse in the formula. Okay? So in that case, I am going to check whether 20 squared plus 21 squared is equal to 27 squared or not. I'm not sure about that. This is something I'm going to check, okay? So let's do it one by one then. Let's check first what the value is of 20 squared plus 21 squared. Okay, so 20 squared plus 21 squared is 400 plus 441. So then I will have 841. Okay, and then 27 squared. If you know it is easy, and otherwise we are just going to check. 27 squared is 729. So 729. So in this case, clearly 20 squared plus 21 squared is not equal to 27 squared. So answer is no. It is not a right angled triangle. If the result is equal, then you can answer yes, it is a right angled triangle, but in this case, it is not. Another thing handy to remember is the formula for area of a triangle. So it's very simple. Area of a triangle is just base multiplied by height. It has to be a perpendicular height and then divided by 2. Okay, so it's just base times height divided by 2. Remember, base and height has to make 90 degrees angle. They have to be perpendicular. And remember that there are some special cases. So for instance, in a right angled triangle, if you take one of the side which is attached to the right angled here as the base, then the other one obviously will be the height because they are perpendicular to each other. Okay, it's not necessarily the case all the time. Of course, you can always take the hypotenuse as the base. Okay, if you take the hypotenuse as the base, then the height of the triangle then has to be this one. It has to be a perpendicular height. But most of the times, then for easy kind of calculation, then we can take the two sides here, which is attached to the right angle as the base and the height. Okay, so for an obtuse triangle, then if you, sometimes it's a bit of a strange situation because then you have a base here and the height, you cannot make a height which is perpendicular to the base inside the triangle. So sometimes the height has to be outside it. So this is a bit of a strange situation. But not to worry, then if you have this kind of case, then the area of the triangle, for instance, in example B, will be the base, which is 15. So the base is just here. It doesn't go up to this side here, okay? So it's just 15 and then multiplied by the perpendicular height, which is 7, and then divided by 2, and then you can calculate this yourself in your calculator, okay? So just a simple reminder of area of a triangle. Good luck!